Hello again. This is Sister Joanne, and I am going to explain the very first problem of the worksheet 4C in a little different way. We're going to do non-graphing solution. And the reason for this is that there sometimes comes a point in which there are more than one variables and that there are three or more variables, and sometimes it becomes hard to graph when that's the case. And so, for that reason, I'm going to show you a method of finding this when you do not necessarily have a graph. One way of doing this is through finding all the possible corner points. And that involves a lot of finding the points of intersection between two graphs. And then when we narrow it down, we're going to narrow it down to find our corner points. And then finally, we're going to test each of the corner points. But first, we need to find all the possible corner points that we can find. And to do that, we intersect the lines of like x is equal to 0 is one of our lines, and then 2x plus 3y is equal to 13. When we do that, when we put in the 0 for the x in that equation, we have y as 4.33. If we put in x is equal to 0 for x plus y is less than or equal to 5, we get 0, 5 as a point of intersection between the line x is equal to 0 and x plus y is less than or equal to 5. When we do the same, we put in 0 for 3x plus 2y is less than or equal to 12, we get the point 0, 6. Remember, these are possible corner points of the feasible region, not necessarily the corner points. And again, when we put in y is equal to 0, and we intersect that with each of the other points, we get 6.50, we get 40, and we get 50. In order to do that seems like an awful lot of points. We are going to narrow it down. And then we look at the other lines. Remember, a corner point is found when two lines intersect. So let's take a look at that. What happens if 2x plus 3y is equal to 13 intersects with x plus y is equal to 5? We do get the point 2, 3. You're doing this. I use the process of elimination, and I had 1y is equal to 3. Therefore, x is equal to 2. I again then did x plus y is equal to 5, and I wanted to see where that line intersected with 3x plus 2y is equal to 12. In this case, you have to try each and every one. And so I did, and again I got 2, 3. I didn't think it was necessary then to test 2x plus 3y is equal to 13 with 3x plus 2y is equal to 12, because I thought that if these two intersected at one and unique point, 2, 3, and these two lines did, then obviously the 2x plus 3y is equal to 13 and the 3x plus 2y is equal to 12 must also meet at that point. So now we have some feasible regions. We have the corner points narrowing down to 0, 0, 0, 4.33, 40, and 2, 3. Now you might say, why didn't I use the 0, 5 and the 0, 6? or the 6.50 and the 50. If you will recall, in order for it to be a corner point of the feasible region, it must satisfy every one of the inequalities. And let's just take a look at 0, 5. If I put in 0, 5 in the first equation, if I substitute 0 for the x and 5 for the y, I get 15 is less than or equal to 13, and that's incorrect. Again, if I put in 0, 6 for x plus y is less than or equal to 5, I get that 6 is less than 5. And again, so I think it's really important that you can then eliminate some of these. You can eliminate 0, 5, you can eliminate 0, 6, and for the same reasons, you can eliminate 5, 0. If I put 5, 0 in this last equation, I won't get a point. I won't get a true inequality. And the same thing goes with this. So I have a lot of possibilities, but now I have to narrow them down. And 2, 3 and 0, 0 also can be listed because they satisfy every single one of them. So let's now go down and take a look at our corner points. If we try each and every point. Now, by trying each and every point, we go back to our optimization function or our objective function. People call it different things. But our objective function, we find that the point 2, 3 satisfies it to the greatest extent, and that maximizes it. So you try each of these points and you substitute the x for the 2 in this case, and the 3 for the y, the 4 for the x, and the 0 for the y. Hopefully this helps. And if there are other methods, and there are other methods, there is something called matrices that you can also try to find the solutions to some of these. But this is one way of doing it without finding the solution without going through graphing. I hope it helps. Thank you.